Hello.
Hello.
Sorry about that. Slight technical issue. But I believe everything is set up now. We're all on the stage. And welcome, folks. Another live presentation here where we're going to talk about a little bit of Skaffold and how it helps to improve your developer's inner loop velocity. Skaffold is open source. It's free. You can go out and get it at skaffold.dev. There's a wealth of information there, some very well laid out documentation. But Giovanni here is going to talk to us a little bit about it. So if you could please introduce yourself, let the folks out there know who you are, and we'll get started.
Yeah, absolutely. And thanks a lot for having me here. And I'm Giovanni Galloro. I'm part of the EMEA app modernization practice in the customer engineering team here at Google. I'm focused mainly on DevOps tools, developer experience tools, and container-based runtime provided on Google Cloud.
Excellent. So I guess before we start, I want to know, why do you think it's important for folks to know about Skaffold?
I think it's important because the problem of developer velocity, developer productivity, developer experience in general is something that is, I think, talking with organization, companies, customers, it seems always more important. There are a lot of organizations that are trying to understand how to improve the life of the developers, because they have more and more people developing software. Also, companies that do not develop software as a core business, no? And on the other side, Skaffold is like, in some way, a kind of hidden gem. Is an open source tool. Is not a commercial product, but it has been created to solve that particular problem. So the people that created that had already this problem in mind. So this is why I think this is important.
Nice. So essentially, there's a really awesome tool out there. It can solve a lot of problems, but it doesn't get enough love from the community at this point, so folks are still having the problem. So hopefully we'll be able to clear some of that up today. All right, let's go ahead. Kick us off.
Yeah, absolutely. Yes, and talking about Skaffold, I really want to try to start from the problem it tries to solve, no? And to talk about that, I would like to start from a research that I came across lately. This is a research from this year. This is not by Google, by the way. This was published on the Association of Computer Machinery Journal. And the authors are Nicole Fortsen, that is one of the authors of the Accelerate book, and other people from a company called Dix that does some analytics on developer productivities, and an author from Victoria University. But it's interesting because it tried to focus the as they say, the dimensions, the 3 dimensions of developer experience. No, the research is around developer productivity, and they try to focus on the 3 dimensions of developer experience, and they focused on these 3 things: flow state, feedback loops, cognitive load. Okay, where flow state is that state that probably all the developers know, and a lot of us doing some type of work know, where you are deeply engaged with your work, where you don't realize the time passing, where you don't have distractions, when you don't switch context, you don't go elsewhere, you are in that tool, you don't feel like you don't go to drink water, you don't go to eat, you don't go. This happens sometimes. No, you just
it's like when you're in the zone.
Yeah, exactly. And another thing is the feedback loops. So how quick I get the outcome of what I'm doing as a developer, how quick I realize the outcome of what I'm doing, how fast is the test to complete and to give me a result, how fast is my continuous integration, how quick I got the code review that is in my code process. And the third thing is the cognitive load. So how is easy to find the information that I need? How is easy to get to the right source of information, the right documentation, or like how is easy or is a challenge to work on code that I'm not, I didn't produce it, code from that I find inside my organization. And I think even this research is really it has been published recently. I think that at least the first two things were already in the mind of the people that created Skaffold, no?
Yeah.
The flow state and the feedback loops, and are really relevant. Because if you think, we focus on people that wants to create application to be deployed in containers, and especially application to be deployed on Kubernetes. If you're focused on this kind of applications and you want to some way test how your application will behave when it's deployed on the target environment. So you want to see how the application will behave on a target cluster, for example. You have to do a lot of tasks. You need to build your container image, eventually tag your image, eventually push on a remote registry if you're going to deploy that on a remote cluster. You need to execute tests eventually, and you have to manage all the deployment part. You have to manage the Kubernetes manifests and render manifest and use that manifest to deploy. And if, for example, your target environment is not is not exposing your application remotely, you need to forward ports on your local host to access your application. And you have to repeat this for every change that you do on your application. Now, while you code, you need to do this again and again. No? And
yeah, it's a lot of stuff to do.
Exactly. Yeah. And I think this can impact negatively both the flow state and the feedback loop. No? And besides the task that you have to do, you need to use multiple tools. So you're coding inside an IDE, but then you need to use a tool to build your application. It will be Docker on another tool. You need to use a tool to manage your manifest. You need to use something to deploy your application. And these things is both like switching context. And this switching context will probably expose you to more distractions, will get you outside the flow, and will make your feedback loop probably longer.
Yeah, totally. Because I can see that as a developer, the more we shift left, the more we ask of them to do, right? So now your devs are being asked to build containers and manage, at least understand the basics of how a Kubernetes cluster works to get their application deployed onto it. And in the past, that really wasn't the case. That they built their code, they said, hey, here it is, here's maybe an exe and a couple of DLLs, and then they would be placed in the proper folders and initialized. Now we're doing a lot more, right? It's a whole new set of skills that are being asked of these developers.
Yeah, exactly. Yeah, it is not enough to just do a Maven run on my PC or Python and run my application on my PC. So there is also the cognitive load thing, no, in this case. So this is basically what the people that created Skaffold wanted to solve. And the first thing that they had in mind is what we need is a code reloading for Kubernetes. We want something that while a developer is coding, is changing its application, continuously monitor its code and deploy its code on a target Kubernetes cluster, a test cluster where it can monitor what is happening. It can get the outcomes of what it's doing. Okay, and this is why Skaffold has been created. And as you say, you can learn about Skaffold in detail on Skaffold Dev. It's an open source project. Is a cloud native developer productivity tool. This is the repo where you can get it, where people can get it. It's part of Google Containers Tools. basically it condenses all the tasks and all the tools we mentioned in a single command, Skaffold dev. With
Nice.
this,
So let's dig into that a little bit more, because I think that ties perfectly with what you said before about that hot reload. So it sounds like what we're doing here is we're going to have a developer environment where you use a developer, you type in something as simple as Skaffold dev, it takes care of the building and the deploying, but also because of hot reload, you're going to be able to see the effects of a coding change almost in near real time without having to go through all of those steps again to rebuild the container, to redeploy the container, and to do all of those other steps. Is that what you're getting at?
Exactly. And if demo codes are with me, I will try to show an example of that later. But yes, this was exactly the point initially. This is the main thing. So I want something that while you code, you immediately see the outcome of what you're doing without touching anything. So you're just in your IDE, you're just coding. Eventually, you click on a link and see something in the browser on your local.
Yeah, that's pretty slick.
Another aspect is that it has a declarative and portable config, because Skaffold is based on a configuration file that is a declarative configuration file. Skaffold has two main components. One is an executable. Skaffold is a command line tool, and another one is this configuration that has a declarative approach, and then, as we will see, can be used in many stages of a delivery pipeline, even starting from the inner development loop. It has a pluggable architecture because it manages the build, the deployment, the test, but it can use different tools to do that. For example, it can use Docker to build an image. It can use build packs. It can use Git. It can use Canico. It can use a local environment, or it can run Canico on a remote Kubernetes cluster. It can drive also cloud build running on Google Cloud, for example. And from the deployment point of view, it's the same. It can easily deploy something like kubectl, or it can integrate with Helm or with Kustomize for more like sophisticated deployment scenario. And the goal is the one that we were discussing before. No? The goal is to shorten this inner development loop, to optimize this inner development loop, continuously deploying the software I'm coding on a target development cluster, on a test cluster that is for the developer to check what he's doing. Okay.
So that development cluster could be as simple as like a mini cube or something like that, or it could actually be a real cluster that's in the cloud.
It can be any Kubernetes cluster. The point is that anything that can be managed with a kubeconfig context will work with Skaffold. In some cases, maybe you would prefer to have something running locally because you want something running in your workstation or in a remote workstation, as I will show in an example, because maybe you don't have something deployed remotely just for your testing, no? But you can point any cluster that you want, that you can manage with a kubeconfig. So going to see the use cases, as we said, Skaffold has been created with this continuous development in mind, no, that we talked about, but now its usage has been extended. So the capabilities have been added. And you can also use Skaffold to build your image in, let's say, independently from this continuous deployment loop. You can use Skaffold to build your image and to render your manifest for specific environments. And for example, provide this manifest and this image as the assets for a GitOps deployment flow. Okay, or you can use in your continuous delivery pipeline totally. So you can use that from the development, build to the deployment on target environments.
Nice. So it can either plug into what you have, or you can use it for the whole path itself.
Exactly. This is an example of the scaffold configuration file I wanted to show, because as I said, what drives scaffold and what scaffold is composed about this two things, this executable and this configuration file. This is an example. This configuration file has three main sections. Let's see in this way. It can have more things, but it has three main sections. One is related to the build. So you are telling Skaffold how to build your image or your images, because this is not one image at a time. It can be more than that. It can be a microservice-based application where you have multiple microservices that needs to evolve together. It has a test section, so you can also automate some basic unit testing with Skaffold. So you want to check that, you do a curl to a specific endpoint where your application starts, or like launch a JUnit test. And it has a manifest section that it manages the deploy. It was called the deploy before. Now they changed the name because it became more articulated around manifest rendering and deployment. Okay.
Yeah, as it grows, it just kind of changes because it's not just that thing anymore.
Exactly. And this is something that is like can sound familiar with people that work with Kubernetes. Now, it's a YAML. It has like a structure, like a kind of API, an API version, etc. It's not exactly a Kubernetes resource, but is very as a structure that is familiar to people that works on Kubernetes.
Yeah, I think if anyone's worked with YAML files, it'll look very familiar. It behaves a lot of the same way. Look out for how you've structured it. Make sure everything lines up properly.
Exactly. Mm-hmm. And as I was mentioning before, one characteristics that it has. Now, we were telling about a portable configuration, and because it has this kind of pluggable approach where you can use different tools for building. Now, you can use, as I said, you can use Docker, you can use build packs, you can use other things. And on the other side, you can use different tools for deployment. And in this way, you are not forcing all the people involved in a delivery pipeline to align on the tool they want to use. So if you use a scaffold, if you standardize on a scaffold configuration, you can have the people involved with development to choose the tool they want for building, for example, but you are not impacting the people involved with application release, because they have the freedom to choose like a GitOps tool with Customize or with Elm, or doing this in another thing, because the common ground will be that configuration file. Okay. So let's go more on the practical side. Let's try to see something more practical. This is this scaffold dev example. As I said, one command, scaffold dev. When you launch that, it basically builds your image, push your image on a target registry if you have to, if you want, and if you configure that, if you have to deploy that on a remote cluster. Render manifest, deploy your application, forward the parts of your application on your local host, and continuously watch for updates when you build that.
Yeah. Before we go forward, can I ask you to talk a little bit more about that render and deploy? I think some folks may not be used to those terms. They just hit go and it goes, but it actually is doing more.
Yeah, absolutely. Can I ask you to wait, because I have more details on that in the example. So sure. I will go in details of that. So basically this was a single thing, no? Okay, I have a manifest and I deploy that, but for how the different tasks that Skaffold does work together, we can articulate this better in 5 minutes. So I want to show some practical example. To do that, I will use a cloud workstation. Cloud workstations are development environments provided by Google Cloud that you can access using a browser or using JetBrains Gateway if you're using JetBrains IDEs like IntelliJ, PyCharm, or Golang. And they have the advantage that can be provided and managed centrally and continuously updated centrally, and they live inside the VPC and the project of the organization where the developer works. So it's easy to provide access also to the organizational resources. On the other side, the developer has his environment ready in a minute from any device, and it's also more secure because the code is not like traveling on laptops. It lives only inside the organizational VPC. But having said that, we use that for our commodity, for our convenience. But basically, you can use Skaffold wherever you want. You can use on a Linux machine. It's an open source tool. You can use on a Mac. You can use on Windows machine also.
Yeah.
So let's. I would like.
But we are fans of cloud workstations. Super huge fans of it.
Yeah. So let's try. I want to start. Let me check what I have now, what I have here. So let's start to open folder, or maybe let's clone a repository. I have a repository with some example application. This is basically on my GitHub personal account to show some example. So let's try to clone that on my workstation, to clone that locally. Yes, we can do that. Okay, I have this repository with some examples here. Okay, I will start with a very simple application. It's a Go application. It has a Go file. Well, basically, it displays on a home page this message, app server ready, running in target, where target is the value of this target is provided by a variable called target, and it has a Kubernetes manifest with a simple service and a deployment that set the value of this target variable to dev, to the value dev. Okay, it has a Docker file to do the build. It doesn't have a Skaffold YAML file, a Skaffold configuration file. And if you don't have that, Skaffold can create a basic configuration file for you. So if I run Skaffold init inside this folder, Skaffold should propose me a possible starting configuration. Okay, and in this case, is proposing me this file structure, and is proposing me to use Docker to build my image because it detected the Docker file inside the repo. Okay, so I can say yes. Okay, this will work for me. So now I have a Skaffold YAML file inside my repository. I can start to work with Skaffold, but I have other examples.
Yeah. Well, so that was really neat. So even though if you're coming to Skaffold and you're new to it, and you want to get started, you don't have to necessarily know how to build the file right away, because if it's a fairly simple deployment, there's a Docker file there, it'll pull that and create that structure for you.
Exactly.
Nice.
Skaffold init. And by the way, here I have the Kubernetes manifest already, but if you don't have the Kubernetes manifest, it can also create a starting Kubernetes manifest for deployment and service for you. Okay,
Very nice.
And obviously you can start from these assets and eventually customize for your needs. I wanted to show some other examples because, for example, I have another application here. I have another example here. This Go full folder. It's the same application, but it doesn't have a Docker file and it has a Go mod file. So if I go there, if I try to go there, and I run a Skaffold init again. Let's check that. As you can see, I have a different structure proposed to me. Skaffold is proposing me to use build paths in this case. because it doesn't detect a Docker file, and it also detects, based on the project structure, it detects that this is probably a proper Go project. So it knows that it can merge that Go code with the appropriate buildpacks builder to build that image. Now, buildpacks is another way to build container image where you don't use a Docker file, but you have this kind of builder image that are ready and that have the logic inside, the code inside, to appropriately merge the code from a specific language application and language code in the proper places, so and build an image. Okay, I will not do that, but just to show an example, I have another example here. I have a Java folder. Okay, this is a Maven project, and for example, if I go to that and do a scaffold in it again, now he asks me, he say, hey, I found different thing here. No Docker file, but is a Maven project. So you can use a buildpacks as well, because buildpacks
an option.
Yeah, it's an option, knows how to build a container image from that. But you can also use the Gib Maven plugin. This is another tool. This is a plugin for Maven that basically, when you do build compile tasks in Maven, it actually builds also a container image. Okay.
Yeah. So it's smart enough to understand that there are multiple ways you could actually handle a Java application or a Maven application in this case, and it'll give you the option of how you want to handle it.
Cool. Exactly. And by the way, if I had a Docker file, I would add a third option, or do you want to use Docker? Okay. But let's go back to our initial example. I think that I saved that scaffold YAML file. Okay. By the way, as we were saying, this is a basic structure, no? But I can start from that and add other things. So, for example, I want to add a configuration for doing port forwarding. As I was mentioning, I can tell Skaffold that I want that the port exposed by my deployment, by my pods, have to be forwarded to my localhost. Because, for example, if I'm developing on a local cluster, on a Minikube, I don't have anything exposing things externally, but I want to check my application. Or other things that I can add, another thing that I can add is, for example, a test configuration that I'm not, my scaffold init didn't create. No? So I can add this section, I can add a test section, and this is very, very basic. Okay, this is just will echo this message. But the point here is that I can execute anything that can run inside a container. Okay, these are basic tests, but in the scaffold build. So I can automate simple tests like checking that once deployed, this application responds on that specific endpoint, or this file is present inside the container structure. Okay.
Yeah. So, like, let's say you had an app and it had a health check module. You could query the health check module, for instance, get back your 200 OK, and then, hey, everything's fine.
Exactly. Maybe fail the build if there's something wrong, or notify the developer if there is something wrong. I think I'm ready to try the scaffold dev thing. One thing I'm using. I'm trying to use Minikube here. Let's see if I have Minikube probably configured. I want to use a Minikube in my local environment. In this case, is a remote environment because it's a workstation in the cloud. But I want to test things where my development environment is, and eventually I will deploy things later. No, I'm in the so-called inner development loop. No, I will eventually deploy stuff once I merge my code and things like that.
Yeah. So your inner loop stack right now, it's Cloud Workstations as your IDE, Skaffold for your build and deploy, Minikube for your runtime environment, and I see you got Cloud Code plug in there too if you wanted to just check on some of the things later on.
Yeah, absolutely, absolutely, absolutely. This is interesting because Cloud Code is an extension that we provide for different IDEs and in different ways. For example, this interface that I'm using is Code OSS, so the one open source version of VS Code with the Cloud Code extension. What Cloud Code does is basically provide an interface to interact with Google Cloud Services directly from your IDE, provide an interface also on top of Skaffold, and this is interesting, and I have a slide after later to talk about that. But the point is that it's still another step to solve the initial problem, no? Because if I have something running inside my IDE that helps me to deploy applications on GKE, on Cloud Run, or use Secret Manager or run GC machine, interact with Google Cloud without moving off my IDE, this helped me to stay in the loop, and shorten the feedback loop.
Yeah, and even lower cognitive load a little bit too, because these things are just kind of built in. They're there for you. Once you know them, you know them.
Exactly. So what else? Oh, okay. These are my context. I have also some remote clusters in my kubeconfig, but I will use that later. But my default is a minikube, and so let's try this Skaffold dev thing. Hopefully this will work. Okay, as you can see, I launched the Skaffold dev. It built the image. By the way, it did run my test. Okay, and it has deployed my application on my default context, that is the minikube, and is forwarding also the port of my application on this localhost port. So I have my application Skaffold displayed up running in target. That okay, easy. If I go on my code and start to work on my code, I can change my code. I can change.
And this is the proof that it's live. That it's live.
Exactly. I did just type U and they rebuild my application. And now, as I work on my code, as you see, it continuously build my application and redeploy. And by the way, for files that are not that don't need to be compiled, no, that the language that do not need compile, or like HTML static templates, it can also avoid to do this rebuild, but it can also directly inject these files inside the running containers. In my case, I changed the Go source, so it had to rebuild that again. So hopefully, if I refresh my application, I have this code updated. No, and you can go on and on and on with this. You type your code, you work on your code, and you have your code continuously updated. No, I write again, update it again, and this starts again, redeploy. And if I go here, okay, I have my code.
All right.
And this is basically how our inner development loop. I will stop Skaffold dev for a moment and go back to the slides, because what we saw is the continuous deployment, but Skaffold can be used also for other things. So all these capabilities that we saw, like running in a single flow, can be used separately in different parts of your continuous delivery pipeline. So you can use in your continuous integration task, you can use Skaffold to build your image, to run tests, to push your image on a target repository. And for the deployment, you can use Skaffold to work on the application configuration on target environment and deploy your application. And this is where we will try to look at these steps, these tasks in some more details. One thing that Skaffold can do, and another command that Skaffold does, is Skaffold build. So basically, when you run Skaffold build, Skaffold will build your image, eventually depending on the configuration and the command, push your image on a remote repository, and it produces a JSON file, an artifact file, that where it puts inside the data of the image that it produces, the tag that it assigned to your image. So you can use this file as an input argument for your subsequent task in your continuous delivery pipeline. No? You can choose to use Skaffold only for some tasks, only for like inner development loop, only for build, and it's pluggable with other pieces. No, so you can use that file for other tasks. So let's try to see how this works.
Yeah.
Okay.
Yeah. So you really don't have to do it all at once. If you have different tools for different parts of your pipeline, you can say, hey, look, I'm going to use this part. We're going to export it to this artifacts JSON file, and then stuck the JSON, refer to that JSON artifacts file for other tasks.
Exactly. Because the point is that if you have this Skaffold YAML configuration that you can use in multiple parts of your pipeline. If you're a developer and you do the flow that I showed before, you use that in your inner development loops. But maybe that Skaffold YAML, I wanted to show how this can be created automatically by Skaffold, but maybe the Skaffold YAML is provided by your platform team inside a template, okay? And this template can be used in different tasks of your continuous delivery pipeline. So for example, now I'm using Skaffold build, and Skaffold build will always refer to that Skaffold YAML configuration. We'll use the build section of that file. And so let's try to run that, and let's see what happens. It just build the application, and it will create this artifact JSON file. Okay, this is basically the name of your image and as a specific tag. Okay, that in a like unique way identify that image. So you can do that. And so what else? What are the other tasks that can do in a continuous delivery pipeline? And so we go and we come to the question that you made before, related to what is manifest render and what is manifest deploy. Why these are two different tasks? So we have this command called Skaffold deploy, used to deploy your application on a target environment. But this command do two tasks mainly. One is render manifest. What does it mean? It means basically that it takes the manifest that is inside your repo, the base manifest that is inside your repo, that you got inside your repo because as in our example, we had already in the repo. In the real life, maybe a base manifest is provided by a platform team, is part of the structure that a platform team provide to their developers, and hydrates that with that specific image tag that comes from your artifact JSON. Okay, and this is the render process.
So what do you mean by hydrate there? Maybe something that folks aren't fully familiar with.
Yeah. It's like it's like you have something that is dry and you put water on it and it becomes usable. No, it's because you have a base manifest that it has. For example, if we look at the manifest here that we have in our configuration, if you see the image, okay, this tells this name, okay, but this name is like a placeholder, let's say in this way. It doesn't have a repo tag. It doesn't have a tag for tagging a specific image. Okay, this is a base manifest. When Skaffold renders the manifest, at minimum, it will replace this image with what is inside the artifact JSON. Okay, so this is the image that I built, but you can also choose which image. There are also other things that Skaffold render can do, and we will see this in a follow-up step. Besides just rendering the manifest with the image tag, it can also apply different configurations for different environments. And it can do that driving customize or help for doing that. Okay, this is also part of the render thing, and I want to show this in a moment. And by the way, the second task is, once I have the manifest ready with the proper image tag and with the proper configuration for that environment, it will deploy the application on a specific environment. Let's see if I'm able to show that. So we have an artifact JSON, so we already built an image. So I should be able to just run Skaffold deploy. And if I put just artifact JSON as an input, it will use my default context, that is my local minikube. Okay. So if I do that, I have basically that image deployed on my target minikube. If I do a kubectl get pods services on my minikube, I see that I have a pod deployed and I have my service deployed on my target minikube. But Skaffold can do these two tasks that I mentioned. Can be done also separately. No, so Skaffold deploy will do rendering and deployment. Skaffold render, you can also decide to run this in split these tasks, because, for example, you don't want to use Skaffold to deploy your application on your target environment. You want just Skaffold to eventually build your container image and render this manifest, as we said before. Configure your manifest for that specific release, for that specific environment. Because eventually you want to put that manifest on a Git repo, because you have some GitOps tool to drive deployment. So you have some operator like Flux, CD, Argo, or another thing pulling this manifest from a repo and manage deployment in this way.
Gotcha. So you do all like the pre-steps, you get it ready to go, you drop it in your repo, and then another tool from there would theoretically pick it up and take it the rest of the way. So Skaffold can be used whether or not you use Argo CD or Flux or whatever. There's no reason why you couldn't use it with those other tools. Okay.
Exactly. This is part of the pluggable architecture. This is part of the fact that you still have this common configuration and you can do multiple things with that. And obviously there is also the other part, because we said before, deploy is render plus deploy, apply manifest on a target environment, and you can have render just to render the manifest, and then you have the apply command. So the apply command is the second step, so that you have the freedom to use. So you start from a rendered manifest, from a manifest for a Kubernetes resource, for an application that doesn't have to be changed at all. It's ready to be deployed, and you just apply that on a target environment. So I want to also try to show that. I think that to do that, I need to delete what I did before, because I want to redeploy my application. Skaffold delete, by the way, will clean up what Skaffold deployed on a target environment, and I will use this Skaffold render command. So now I am splitting the Skaffold deploy in the two commands, Skaffold render and Skaffold apply. Okay, I'm still getting artifact JSON as an input, because this is the tag I want to use to render my manifest, but I'm also putting an output manifest that I want to produce. Okay, and if everything works, now I have this render YAML file here. Okay, that is basically my base manifest, my base Kubernetes manifest I was looking at before, with the difference that I have the image with the right tag. Okay, And then I can apply this manifest just with the command scaffold apply and giving as an input the render YAML, okay? It applies to my default context, so I should be able to kubectl pod service, and I have that pod deployed and that service deployed. Okay. Having said that, so we are still pointing this minikube file, but the scaffold configuration can be used as the base also for managing deployments and, let's say, progression across different stages in your delivery pipeline. No? And I have an example of that.
Yeah, it kind of looked like you were going there before. I think I noticed you had a dev, a stage, and a prod
Exactly.
listed earlier. Yeah.
Exactly. So let's close these files and let's move to this another example folder, okay? This is the same application basically, but it has a difference. It already has a scaffold YAML file. And this scaffold YAML file is a bit different. As you can see, it has for the deployment, it has a manifest section that points to a specific folder, Kubernetes/dev. And then it has a different section called profiles, where it has two subsections, two profiles. One is named QA and points to this folder named Kubernetes/QA, and the other one is named prod and points to this prod folder. And all these sections use customize. So how customize works? This is just an example, and this is an example we are using to show how to use this configuration to manage the deployment across different stages and different environments. It could have been Helm, for example. In this case, we are using customize. Customize, basically, for who doesn't know that, is it allows you to manage the deployment of multiple Kubernetes resources, or maybe the same different instances of the same application, of the same resource in different environments, managing the configuration from a single common file or a single common configuration, a single common set of files where parameters are common between the different environments, and just adding files for the differences, for the things that changes. So you don't have to manage a lot of different resources and manifests where for the different environments.
Yeah. So like your horizontal pods, the number of pods you spin up, that could be one of the things that you change. And there are lots of different things that, hey, it's the same app fundamentally, but then there are some slight differences between what you do in dev versus QA and versus prod. So to account for that, you would just have another configuration file that outlines those differences.
Exactly. So to avoid, you like condense that. You start from a common configuration and you have just differences. And I can show this in this folder structure. For example, we have this by default, Skaffold will use what's inside Kubernetes dev. What is inside Kubernetes dev? There is this customization YAML file. How customize works? When you deploy something with customize will look for this customization file to actually build the manifest that has to use. And what this customization YAML file is configured for is my end deployment, my target deployment will be a merge between what is inside this base folder and what is inside this target YAML file. This is what is written inside this file. So if I go and look at the base folder, I have another customization file that basically points to deployment.yaml, and deployment.yaml is basically base manifest is similar, is very similar to the one we were showing in the previous example, in the initial example, with the difference that even that environment variable, target environment variable, is not there. Is really the base. Is really just what is common between all environments. But I have this target YAML in dev, no? So if Skaffold use this folder, it will merge what is in the base folder with this, and it will basically apply. It will basically set the value of the target variable to that. Okay, let's look at QA. Similar configuration is a merge between base and target YAML, and target YAML in QA will be set the value of the target variable to QA. Okay, this is simple. This is just to show the difference, but this could be, as you were mentioning, like having a connection to different database system, to different login system, or like different login parameters, or different capacity. As for example, in prod, we have similar configuration, but here, in addition to the target variable with a different value, that is prod, we have also a different replicas configuration. We have more pods, okay, for example.
Yeah, and it could be different ports. Now, this one, it looks like your ports are defined in the main. However, they wouldn't have to be. In some different circumstances, your dev, prod, and QA could all be on different ports, for instance. And so that would be another thing that you could alter if you needed to.
Exactly.
Yeah,
exactly.
But your target and prod, that's just a setup that you customly defined, and so you can call those variables later.
Yeah, exactly. Exactly. This is just to show when we deploy the application that, okay, this is prod, this is QA, but this can be any change, or also more complex change. No, you can have more complex structure. So you start from a base, and from there you build what are all your different environments. And another thing I want to talk about is, okay, we saw how customize, manage the merge or configuration in these folders, but what are these profiles? Basically, profiles are a Skaffold capability that basically lets Skaffold use a specific configuration depending on an input that you provide. So you can provide a different profile as a command line parameter, or as a kubeconfig context, or as an environment variable, and Skaffold will pick what's inside this section, or what is inside this other section, for example. Okay, this is what profiles are about. So now I want to show an example of that. I will use some remote clusters to do that. So I will stop my Minikube here, just to be sure. I don't have a default context anymore. And so now I have in my kubeconfig context, I have this prod cluster and QA cluster that I want to map with these profiles. And by the way, I think that I have to also to use a remote container repository, image repository. No, I will have to do a Skaffold build again, not for the Skaffold build, but for the fact that now I have the image running in the Docker daemon, managed by the Docker daemon in my Minikube. But now, since I want to deploy my application on these remote clusters that, by the way, are
they're on Google Cloud right now. And so if you go into Kubernetes engine, they just show up right there. Yep.
Yeah, exactly. I have my clusters here, but I want to use a remote repository. So I prepared this repository inside Artifact Registry. And this is empty at the moment. It has no images. Okay, it has this path. So what I want to do here, I will run this Skaffold build. File output will always be artifact JSON, but I will put this default repo. So I will have Skaffold build also pushing the image on that repo. Okay, so it will build the image and hopefully will push the image on the target repo where my remote clusters will be able to pull that image from. Where is, okay, if I refresh that.
Yeah, so this is just like in real life where, your infrastructure is in the cloud. And so you're not going to need that image locally anymore. You want to have the image stored in a not a real artifact registry, but a cloud-based artifact registry, or in a registry where it can be accessed by your clusters. And then from there, you'll be able to do your deploy.
Exactly. And by the way, we are using all these tasks, but you can integrate this as part of your delivery pipeline in different ways. No, and there are some Google Cloud tools that also use Skaffold behind the scene, and in this case, we will use the Skaffold configuration to manage the deployment in different environments. So I think I have the image ready. So I think I should be ready to test if I can deploy to different clusters. So let's try to do a Skaffold deploy artifact JSON as I did before, but I put two new parameters. One is profile QA. So I'm telling Skaffold to use the QA profile. And another one is deploy to the QA clusters. Okay, so use what is inside your QA profile configuration and target to the QA clusters. And it will get the image tag from the artifact JSON. Okay, so I think it deployed the application. So if I go to check this time I need to point the QA cluster context, I will see that I have one pod deployed, one service deployed. Hopefully, since this is a GK cluster and it has a load balancer type service, it should also get an external IP.
And you should be able to bring up the app on that external IP, right?
Yeah. But when you're streaming live and we're doing a demo, minutes, no? And
yeah.
Okay, so we got this external IP. So I should be able to see my application in the QA environment when it's ready. Okay.
Oh, look at that. And it says, yep, target is QA. So it's pulling the new values as well. So, it is working. It's doing exactly what it's supposed to do.
Exactly. Yeah. And I can do the same on prod. Okay. I just input a different profile name, prod, a different context, and launch the deploy. It picks the image tag with the repo from the artifact JSON. And if I go to check the prod cluster, I should see my deployment. In this case, is different because we had configured the prod manifest, the target YAML in customize to have 3 replicas. This is an example. Maybe in production, you want to have more capacity to handle the production traffic. Okay. And hopefully the cluster should give
we'll see it eventually. So one thing I noticed though is that, when you said, hey, folks can kind of tie these things into different tools, it reminded me that in Cloud Build even, some folks will use Skaffold as a build step, as part of their pipeline there. And it really is just, I guess, your choice, for how you want to manage your environment.
Exactly. Yeah. I agree with that. I think that the point is that it helps you. What is helpful is that you have this common configuration, no? So when you have all the basic settings for your build and eventually your deploy in a single file, and you can eventually use that also with different tools. So you can use Skaffold Dev. Your developers can use Skaffold Dev, or you can use Skaffold Dev as part of Cloud Code, because I don't think we have time to show that, but Cloud Code can use Skaffold Dev behind the scene to do continuous deployment on a Kubernetes cluster. You can use Cloud Build to do a scaffold build. So, or you can use any runner, any build system to do a scaffold build. But this will be helpful because you will still use that configuration. You will still use this. You will still produce this artifact JSON, and you can use that things in the consequent steps of your delivery pipeline.
Yeah, and all this stuff is open source, so you can use it with whatever. We talk about Cloud Build, and we may mention Cloud Deploy, but there's no reason why you couldn't issue these same commands in a general executing tool like a Jenkins, for instance, or any tool that just lets you run a command.
And by the way, we wanted to show all the things that Skaffold can do besides the inner development loop thing. But if you think about the inner development loop, is really, I think, is really a powerful thing, because this discussion about the developer productivity, the developer experience, I have the feeling that this is becoming more and more important for various organizations. So having something that helps me to be more focused, and we are not talking about, we still didn't mention the word AI. I have also the AI stuff disabled in this workstation. We didn't mention that, but yeah, this is, I think, for developers, this is part of the same attempt to solve this experience and productivity problem.
Oh yeah, I mean, it's really neat because when you look at those factors that you mentioned earlier, right? There's the cognitive load that's on developers from having to learn how to do all of these things. There's just wanting to stay in focus so that you can focus on you want to be more focused on your code than the infrastructure and the stuff around getting the code to execute. So hopefully, that's really is the point of a tool like a Skaffold, and hopefully we've been able to show that to you in this past, I guess, almost an hour now.
Yeah. Time passes when you have fun and playing with stuff, but I think we are close to the end. I just wanted to show if we were able to deploy this to our production environment. Okay, so we are there, and these were the examples I wanted to show. I have a couple of slides just to tell one important thing. One, we already mentioned. We saw the Skaffold. Skaffold is an open source tool. Skaffold there, it has this configuration you can use with your tools. You can automate whatever you prefer. But there are some tools provided by Google Cloud that uses Skaffold behind the scene. One is Cloud Code that we already mentioned it. So maybe not a lot to add about that, but basically Cloud Code is an extension that we provide, is an extension for VS Code and JetBrains IDEs, and that we provide also as a web accessible IDE through Cloud Shell IDE, and also inside Cloud Workstations. That is the workstation I was using before, and that basically has the goal to make the interactions mainly with Google Cloud more like help to interact with Google Cloud directly from the IDE. So not reduce the need to move off the IDE for developers to do things. But not only Google Cloud, I have to say, because if we talk about Kubernetes, what we are seeing here is this Kubernetes Explorer. This will work with any Kubernetes, not just with GKE, okay? So you directly from your IDE, you can deploy your application on a target Kubernetes environment. You can look at the logs from your application, from your IDE. You can access your application directly from your IDE. So this is part of the same solution, okay, to reduce, to help people staying in the flow.
And today everything was kept kind of plain vanilla. It's just normal Kubernetes commands and that sort of thing. Maybe next time we'll, highlight some more features within code. But I think this was important to show that what we're doing can be used by anyone, anywhere. But if you want to do something that's a little more plugged in, we can talk about, no pun intended. We can talk about this in another episode.
Yeah, absolutely.
Mhm.
Cloud Workstation, we already mentioned that. So Cloud Code is also part of Cloud Workstations, and we already mentioned that is a remote development environment provided by the cloud that you can access remotely. And another thing is that Skaffold is used also by Google Cloud Deploy. So Google Cloud Deploy, I think you already talked with Christy about that in another episode. Basically, to recap, is the service on Google Cloud that helps you to manage the deployment of your application on different environments or on different execution environment. That's start from a release and manage the different configurations in different environments. And what it uses behind the scene to do that is a Skaffold configuration. It basically do Skaffold render to render the manifest and Skaffold apply to apply your manifest on target environments, but in a managed way. So you are not running Skaffold yourself, but you will use always the Skaffold.yaml configuration that works also whatever you want in another platform with other tools. But this is managed by Google Cloud managed service. Okay,
Yeah.
so for
Yeah.
the
And it's pretty neat, right? Because now you've taken that knowledge that you have with using Skaffold locally, and you're able to now use it in your enterprise. So that's part of lowering a cognitive load, is having the ability to use the same set of knowledge in multiple places.
Yeah, exactly, absolutely. And this is all I had. I think it was long. I didn't expect it was so long, but when you play with stuff, sometimes time passes. And it was good to not look at the clock continuously because we had more freedom.
Yeah. I mean, this was fun. It's so one of the things, and this show is going to evolve and grow over time, but the point is to just kind of see where we go with the tech. We have a general roadmap, but if we want to take a side road, go for it, right? And I thank you so much for doing that with us, because and entertaining some of those other little deviations here and there, so we could get a little bit deeper into the tech.
It was fun. It was super fun for me, and thanks a lot to you, Nate. It was really, really, really fun.
Yes, thank you. And I'm going to go ahead and say it. You'll be able to pick up Giovanni's book in hopefully a few months from now. So we will keep you updated on that as well.
You mean Nate and Giovanni's book? No, Nate and Giovanni's book.
Yes,
okay,
and Dave.
This is not official, so it's still not official.
Yeah, it's not official, but yeah, the goal is to take a lot of what you saw here, package it up, make it available in multiple forms. So you'll have videos, you'll have books, you'll have lots of different ways to have, to dig into this information a little bit more and digest it in a way that works for you. So thank you, everyone. This has been awesome. Giovanni, as always.
Thanks a lot. It was fun. Thank you.
Yeah, thank you. Take care.
Bye. Bye-bye.